Alright, welcome back, guys. We are starting again, right? Today is 8th day of DevOps and MLOps, right? So today will be our phase 1 finale. Okay. Uh, the phase 1 was our software engineering foundations, right? So today's topic would be Postgres SQL, and second is Streamlit. Okay, so you know these are popular frameworks. Okay, so so now our full loop is covering like UI. From UI we came to API, right? Then we came to model. We have model also, we have API, and then we have a database also, right? Now this last stage is there of this loop. So far our repo, as we can see, if I try to get pull, then I think I am already up to date, so I don't need to pull anything. And first I have to activate the virtual environment also, right? So our virtual environment activated, and you can see okay. So today our plan is to the prediction must being saved to the Postgres. Okay, this is our plan. Today's plan. Let's write it here. Today our plan is all the predictions we asked for, right? Predictions must be saved to Postgres, and the Streamlit page will make the prediction end-to-end. Okay, page making a prediction end-to-end. Alright. Okay, so first we need the to install the Postgres SQL, right? So let me ask somewhere, right? How to install Postgres SQL in Ubuntu. Okay, so sudo apt update system call status. Okay, this is the command, right? PostgreSQL contrib Okay, so let me just write this command. Sudo apt install. Okay, so I think I should install it outside this, right? Outside the environment. I don't know. We can install this here also, right? Postgres PostgreSQL. Okay. And again PostgreSQL contrib. This is how we install it. It will ask my password. I am writing my password here, right? So it's downloading, I think, right? So let it download. Then another thing will be our this we have to install the Streamlit also, right? It's downloaded. Let me ask this thing also, like to install Streamlit SQL alchemy, right? By PSY price psycho G2 binary in Ubuntu, or you can write in Linux also. That's not, you can install Streamlit SQL alchemy binary by setting up a virtual environment running. Okay, so we already have virtual environment, right? Running pipe installer like this. Okay, so update. All right. Let me install that also. Pip install Streamlit SQL alchemy, right? Then psycho pg2 binary, right? And one more thing I have to install is Python .env. Okay, it's everything downloading here. Alright, so it's let it install. Then the yesterday homework was yesterday what we did is we understood the HTTP thing, right? And we built some APIs, right? Like we understood like HTTP is the restaurant conversation, like, right? Our model went online behind a fast API / predict endpoint, and the pydantic we used pydantic to bounces the garbage input, right? With precise codes like 422s and everything. And the auto generated /docs page also, believe. Okay, so yesterday homework we have to do, we needed this thing. Let me show you. Where is our API? Okay. uh, One more thing we have, if the homework was like we have to tell about the model information, right? So we can make a class model info like that, and introduce the pydantic base model, right? So this is for response from our side, okay? So accuracy is of a float type, right? F1 is also F1 is also a float type, okay? Like this will be our the base model for model info, okay? This is using both for pydantic, and now what we can give here is at app.get, right? It's not post, right? It is the get decorator like this, like health, right? So this will get if it asks like, okay, give me the model info, okay? Okay, so give me the model info. If it says, then our this will be our type of response model, right? Response model will be model info, okay? So that's how we can do, and we will define our model info method. It's of type model info here, return type for this, right? So what it will do, it will read the matrix file from the 6th day of pipeline we wrote, okay, next to the model, as you can see here, and predictor, I think predict, you can see, right, other than this, wait a minute, no, I think it's trend.py, right? It's in trend.py. This is matrix, right? You can see matrices, right? These matrices. So we saved here, right? Where we saved? In models, matrix.yml, right? So we saved it. So we will read that also. So for that, to read the YML file, right? We need YML here. So we need to import this, okay? Import YML also, and we need to read some files. So from pathlib, import the path, right? That's what we need to do here, and after that, metric path equal to path. We have this models, right? Inside models, matrix dot matrix by AML, right? That's the file we have in path, and if it does not exist, right? So if not matrix path okay, dot exists, in that case we will raise some error, TP exception with a status code of 503, saying detail. In the detail we will say, okay, no trend matrix found, right? Like this. And after that we can say with the if it is there, path is there, right, file is there, then open matrix path, okay, as f, then we will have a matrix is equal to yml dot safe load. We have to do this f, right, we have opened the f, then we can return it, return model info. Inside model info, what we can do, we can have matrix. Okay, so why these two stars are there? Because we have to dereference it to a get to this level, right, this accuracy and f1, because it will be in dictionary form, so we have to get dereference that, right. So that's it for so the wait a minute, guys. Okay, so today goal, we know this, we will use this Postgres database, because every time this API make any prediction, that vanishes, right, it only exists in the terminal, right. So we have to store those predictions to analyze them later, for, like, for example, drift detection on the of the model, like that we have to save. And this Streamlit it's a Python only UI, right. It's a Python only way to build a web UIs. Okay, so let's understand things like what is a database. Okay, why we need this database? Why just not use files only, right? Because we are already saving files, things to into files, like we already saved our models and vectorizer and the matrix also, right, in the files. So why don't we use files to that? Okay, we can save this prediction to a big CSV file, like So let's trace this example. Let's say the two API requests arrive in the same millisecond. Okay, request 1 and request 2, they arrive on the same millisecond, and both predictions got there, and both appended to the prediction.csv, right? Append to file, and the half line of 1, right? So hello, and half line of 2, namaste, let's say, got written in the file, right? So file is corrupted in that case, right? Now, so the server will restart mid-write and half a line corrupted. So now if you say, okay, find all negative predictions from last Tuesday in a 10 million line CSV, let's say, we have to read everything every time. So what we need to do, so what is a database then? So database is a program whose entire job is to solve exactly these problems. It can perform many writes without any corruption. So it provides us a concurrency, right? And it also, there will be no half written data ever, okay? Like all the write and read will be like atomic, okay? Like transactions will be like all or nothing. Either it will be completely written or it will not be written at all, okay? And searching data and finding data in instant time, so indexes is there, okay? So files are a notebook of your desk, on your desk, okay? And a database is a bank vault with a librarian, you can say. So for example, let me see this. Let's say there is a table, okay? Predictions. What are the predictions? Okay. So let's say this will be ID of ours, and 1, 2, and then text. Text will be like this, okay? Great product, love it. Let's say like that, right? And this text is like broke after 2 days. Let's say, right? This is our text. What will be the sentiment of this? Here it is positive, here it is negative, and its confidence, let's say 0.94, it's 0.97, let's say. And we can also write where it was created at, right? When. So we can write time like, okay, it is created on 16/7/2026 and at time of 9:02:11, like this, right? And 19:03, okay, any millisecond also. So what is a relational database? So this is the example of a relational database, okay? There is thing called a database and there is called a relational database. So relational database store data in tables with a declared shape, okay? So there is only declared, right? We have different rows, but all rows have the same columns, right? So shape is declared already. Okay, so this declared shape is called uh, schema. Okay. Uh, so you can say it's a pedantic thinking applied here also. We have to declare the shape, the system enforces it. Okay, if you don't write according to the shape, then it will reject it. Okay. Okay, this is you know what is database and all. So Postgres is relational database only. Okay. Now next thing is for us the SQL. Postgres, you know what is it is a database, but what is SQL? So SQL is like full form for this is structured query. So it's like a 50-year-old language. You must know how to speak it. Okay. So it was created in 1974. It's older than Python in a sense. So I think it also outlive us all because we didn't born that time, right? So in this SQL structured query language, with the help of this language, you describe what you want, and the database figures it how it will do it. Okay, so it's almost English like okay. One thing is select uh, sentiment. We want to select sentiment column, right, from this table. As you can see here, this is a sentiment table, right? Sentiment column. Count asterisk. I will tell you what it is. Okay. Okay. Then you can say here from what is the table name? We need, table name is prediction, right? Uh, Predictions. You can say predictions. It will look more correct. Okay. So from which table we want, and some conditions should be there to like pinpoint like which row you want, right? Where created at is greater than this date 2026 7/15. Okay, so whenever is greater than 15, so it's 16, right? So I think this both qualify for this condition, right? So and then again next thing is group by sentiment. Okay, so what it is doing like so you can say select is similar to we saying okay read it, right? Read it. It is similar, very similar. Okay. Uh, so we have to read these four. Let me tell you one more thing before explaining this query. Four horsemen you must know. Like one is select. Okay, this is select. So it's like very like similar to read. Okay, I am saying database read it. Okay. Then next thing is insert. Insert means we are trying to create it or like add something. Okay. And audit is to modify, and delete is to remove something, right? So these are our CRUD operations, right? R, C, update U is here, delete, right? So this is CRUD operations. Uh, so every app you ever see or use, right? It's just CRUD operations with some UI. Okay. So we will write some raw SQL here first by hand today, and you must see it, then let the tool write it for us. Okay. So one more thing, what I'll be doing, like just a simple English. Okay, so read sentiment from this prediction table where created at is this, and group by sentiment means how many positives is count, how many positives is there. Whenever you use group, then this aggregate function will use. Okay, how many positive sentiments are there and how many negative sentiments are there, like just like that. Okay, that's how we do it. And next thing you heard a lot is this Postgres SQL and SQLite, right? So this SQLite is like it's like a database in a single file. Okay, database in a single file. It needs zero setup. It's very useful, brilliant for phones and prototypes. Okay, because it only supports this one writer at a time. Okay, this is a limitation of SQLite. Okay, but this Postgres there is one more thing is MySQL. Okay, it's also a good database. It's fine and it is used everywhere, right? But it is aging, it is like old, but this is special. Okay, this science like outscience all of them with this it is modern and modern default, you can say. All of them, all of industries using this. Okay, uh, rock solid, it has many features. Okay, so it's feature rich also, and it's open source. Okay, and it's also most loved surveys and developer surveys year after year. Okay, so because we are choosing this Postgres for a strategic reason beyond the popularity of its. Okay, on day 39 it's PG vector thing. Okay, there is a called thing PG vector extension turns the same database into a vector store in our reg assistance. Okay, so one database is there and classical is here plus AI workload also it's handling. So Postgres is very useful in MLOps. So learning it once will pay us twice. So that's the thing. Next concept for us guys is this ORM, very important. What is this ORMs? Objects meet tables. Okay, uh, so you can see the our app thinks in the Python objects, right? What are the objects are? In dictionary you can say, right? These are objects in list, right? So Python thinks in objects, but database thinks in rows, right? It has rows. So these rows are there. So row 1, row 2, like this, right? This predefined schema is there. So database thinks in rows, right? So someone must translate this constantly, or also in both directions, right? So by doing it by hand, it will be so much boring, right? We will keep writing SQL strings forever, right? Also, we can risk SQL injection also in that case. There was a classic attack where user input smuggles SQL commands, right? And so it hacked injected the SQL, the commands in the SQL, right? So this ORM is object relational mapper. Okay, it's a professional translator. What do? You define a Python class first, okay, which creates a table. You save an object and it writes the insert for you, okay. If you query with Python methods, it writes the select for you and it parameterized everything, injection, okay. So proof by default is there. It's also injection proof by default, okay. So we will use this SQL alchemy, okay. So it's Python's standard ORM, you can say, object relation mapper, okay. So there will be a rule for us. We will follow that, okay. First we will understand the SQL, then we will write the ORM, okay. And next thing, guys, is very important. Environment variables, okay. We have to configure it with secrets. So database needs a password, okay. So whenever you access some password, it needs a password, access to data. Whenever you want to need access the database, it will need a password from you, okay. So where will you save this password? Where does this password will live, right? We cannot write into the code, right? Because Git will remember everything forever, so we cannot public it, okay. And we also cannot put it into a trend.yml. This also committed, we already committed it, right? So we need environment variables in this case. So what is this environment variables? Here values will live in the, let me write it, values living in cell environment. What do I mean by this? It will be outside any Git files, okay. So you see, there you I think you in development well you already see this .env file, okay. So what is this file? This file is just a local file, okay. It lives locally. It get ignored file. We already ignored this. Here you can see, I think, and this get ignored. We didn't do this, okay. This you can see, right? So .env is there. we already ignored it, so get ignored, so it will not to committed, will not be committed to get, right? Get ignored file, it's you can say key value lines only, okay. It will be loaded at a startup. uh, So you can see we already on day 4 I think we built the get ignore file. So we already added this .env, right, before adding any secrets here. So today this prophecy is fulfilled here. Our first secret will arrive here, and the protection was already waiting. Okay, keep coming. We will protect it, right? Like that. This pattern will scale all the way up for us, like in GitHub Action secrets, Kubernetes secrets. So there it will be the same idea for us, and on the bigger stage, right? So we need that to access the database. We will keep this password here, right? What is a transaction? Okay. What is a transaction? You know this database provides us transaction. I told you like here this whatever this concurrency, we can write like two things or read two things one at a time, right? Transactions and indexes. So what is transaction here, right? So you can define a transaction is like you do a transaction in ATM and all, right? So you can say like when you a transaction is a group of operations that succeed or fail as one unit. Okay, like you say okay, give me you pay me the, like you go to ATM and enter your PIN and you withdraw some money, right? Like say 5,000 rupees. Okay, 5,000 you are withdrawing. So you enter your PIN. You start a transaction. You enter your PIN. You write 5,000 first. You enter your PIN, and you press enter. So after enter, there are so many transactions. Okay, it will check. Okay, is this balance is there or not? It is the same PIN or not, right? Validate, authenticate. These are operations, right? These operations will, if let's say this operation execute, this operation execute, if it lights cut off, so these both operations will also roll back. Okay, either these three will execute successfully as a one unit, else all of them will roll back. So that's the atomicity we are talking about. Okay. So this transaction provide us these things. Transaction provide us acid properties. Is what is acid properties? One is atomicity. C is consistency. I is I think isolation, and D is durability. So you can memorize this acronym. It is very important. Okay, and this is transaction, right? And next thing is SQL injection. What is SQL injection and how we prevent it? Okay, what is this? What happens is a user input like this. So some user in his name, let's say in the column of is like logging in or anything, right? It can concatenate into a SQL string. Okay, like that, like this. Drop table, like this. Okay, So a user can give input like this, right? Drop table. If everything is executed in the SQL or database, right? If everything is being executed, so this SQL injection, it will drop the table, right, by this command. But how to prevent it? We prevent it by the parameterization of queries. Okay, parameterized queries, or you can say ORMs. ORMs also parameterize the queries. Okay, so the lesson from here is never string build SQL from input. Okay, like that. What is an index? What is an index? You can say index is just a it's a let's just a lookup structure for you. Okay, so like you have any books index, right? Like to look up at a speed, like read fast on a column like that. Okay, so without like you don't need to full scan the table and all, you can fastly read something. And we will also add one index today, so you will know also why we are adding it. Okay, and this thing is why not store everything in a giant table? That's a problem also. So many problems are there. Okay, to when we store everything in one big file. Okay, one big giant table, we cannot do that because first is normalization. Okay, what we do, we split related data into linked tables, right, to avoid duplication. Okay, duplication also, and update anomalies also. Update anomalies. So we are using just single table today, but normalization will matter a lot when reviews will meet the product and products meet the user. Okay. Okay. So these are the just simple concept and theory of this for today. Let's go to coding. It's already everything is installed, I think, successfully, right? Streamlit and PostgreSQL and also this ORM, right? What was the ORM for us? Python ORM was the and the SQL alchemy, right? Okay, so let's create the branch first. Get switch if a branch is not there, feature, right, slash database and UI. We are doing that right today. You can do that, and we already installed this PostgreSQL, right? So we already started the install the PostgreSQL server, right? Let's just start the database server, right? Sudo service PostgreSQL start. It will asking password because we are running the sudo command, right? I am writing my password. What happened? So it has started the server in the background. Okay, so this will listen us to the connections for us. Okay, default port for this SQL is 5432. Default port is this. Default port for is 5432. So you should remember this. Okay, like ports are doors for us from day 7. You can I was explaining you. So also the database also has its own door, right? So it's running in background, and the door for this is 5432. Okay, and why we use this service? Okay, here on WSL, right? So this command has sudo service PostgreSQL start. It has started server PostgreSQL server. Okay. What is server? A server is just simply a program that keeps running and waits for request from you, right? So think of like a bank. Like bank opens at 9 a.m. and employee sits inside that, and customers come all day, and employees serve those customers. So similarly, what happens is PostgreSQL server start, and database waits for requests, and application will connect to it, and database then answers to this request. Okay. It runs in background because so when you start Postgres, it does not immediately exit. Instead, it keeps running, right? So it waits until some application asks it something. So it has to run in background, right? So there is called listens for connections. Okay, what does they mean? Like imagine your phone. When it's turned on, it waits for calls, right? Phone is on, it's waiting for calls. Someone calls and phone answers in this case. Similarly, database is on there. It's waiting, and application connects to it, and database answer that. Okay. And it's used this 5432 port. As you know, like every server always listens on port, right? So for PostgreSQL is this port is 5432. It is default. Okay. So why we are starting this PostgreSQL first? Okay. Suppose you have a FastAPI application start, right? And it tries to connect with database, right? If PostgreSQL is running, then it can connect and reply back, right? Everything will work. If this PostgreSQL server is not running in that case, then when fast API is like connection app says hello, then nobody answers that, right? So you will get an error in that case. So we have to run this database first, right? What is this WSL and Linux? So in native Linux, most Linux system use a program called systemd. Okay, you know, most Linux run use a program. Let me color the change. Use a program called systemd. So this systemd manages background services like PostgreSQL, Docker, engines. Okay. So what you do is you usually start Postgres with this command: sudo systemctl start. Okay. PostgreSQL. Okay. This. Let me write this to PostgreSQL. Okay. What is WSL? It is a Windows subsystem for Linux. You know, is a lightweight Linux environment inside Windows. So older and default WSL setup often don't use systemd. So the common command is this: sudo service PostgreSQL start. Right, this is common command. So these both commands, this command sudo systemctl start, this command and this command, both essentially do the same thing. Okay, start the PostgreSQL server, but it's for WSL here. It's for Linux. Okay. So next thing, we need to open the SQL, right? For that, this is a command called sudo u postgres psql. So what is this psql? So this psql, it's a program, okay, that lets you talk directly to PostgreSQL. Okay, so you can think of it as a chat window. Okay, so you are here and PSQL, you will communicate to this PSQL, and this will go the PostgreSQL. PostgreSQL. Okay. PostgreSQL. This will, instead of writing Python code, you just type SQL commands directly in that case. Okay. So there is a new concept called REPL. REPL. So R is read, evaluate, evaluate, right? And P is for print, and L is for loop. That means when you type something, computer executes it, and it will print and show the result and wait for the next command. So it will read your command what you have typed, and then execute means evaluate, and print the output, and loop for the next command, right? So in Python you probably used like these things, right? These 5 plus 3, when you press enter, it immediately answers 8. Then it waits again for you, right? You can say len of what is the length of this string. It immediately answers 5. Then again waits, right? So that's the same thing here. So with PSQL, it's the same idea, but for databases. Okay. So what happens is you type this select 2 plus 3. Let's for example this PostgreSQL reply with 8, or 2 plus 3 is 5, right? Okay, like this. Then again waits. So why we are using PSQL? Because suppose let's say your database is not working, right? For example, so instead of guessing, what you can do, you can open PSQL and ask the database directly, like from select like this, select asterisk from users. This is a query, SQL query, right? If it returns data, you know the database is fine. If it is given an error, the problem is in the database. So it will make debugging much more easier. Okay. So as I told you, this service is for WSL, for window users, but I am not a window user, so I need something different, right? I need this command, I think. The sudo system ctl start PostgreSQL, right? So sudo system ctl, right, start PostgreSQL. Okay, so it's running. I think it must be running in the background. And now what I will do, I will do sudo u Postgres PSQL. Okay, this has opened the interface for us. Okay, so it will open the PSQL for us. So this is the Postgres REPL for us: read, evaluate, and print, then loop, right? This is the Postgres REPL for us, and it's the same spirit as the Python's REPL for us. Okay, it will poke the database directly before any code. So first what we will do, we will create a database. Okay, so we should have a name for a database. So it will be container for our tables, right? So one server can host many databases because it's just a program, right? So it can run many programs. Okay, so what we will do, create, it's a like capital, right? Database is review radar. Okay, so create database is there. Create database is created, I think. Now what I can do is create user. Okay, we need some user also called radar. Okay, radr, let's say, with the password. Should I tell you the password? Because it's in local, you are not hacking my system, so just simple password, let's say radar underscore dev underscore password. Okay, so this is our, so this is, we created a dedicated user for our app. Okay, so this dev password will be local only, it will never touch git ever. Okay, so it will still never touch the git. And next thing what we will do is we will grant some accesses. Okay, grant all privileges on database, which is review radar, right? To user is radar, right? We are pretty getting, so all the privileges are granted here. Okay, and alter database review radar, okay, owner to radar. So what happen here is it give our user full control of our database. Okay, nothing else, just the owner of this database is now the radar. Okay, that's it. Let's see one thing, let me show you review radar. So it's just saying you are now connected to database review radar as user Postgres. So these backslash commands are the PSQL's own commands, it's not SQL commands. Okay, so all of these were the SQL commands, but this backslash commands is for PSQL. Okay, so let me create some table for you. In this case, I am connected to the database, right? I think user is radar. Why it's saying Postgres? I don't know. We will see if there are problems is there. Okay. So let me because I am connected to this was the Postgres database, right? But now we are using the radar database, right? Now what we will do? We will create a table, right? With relation, right? So let's test predictions, right? You can see like this. Wait. What happened? Let me do this. Wait. Okay. Create table test predictions. Okay. ID is it will be a serial. Okay. Serial and it will be also primary key for us. Okay. Serial is just auto incrementing. It will automatically increment, okay, integers, and primary key is like unique row identifier for us. Then we will have text column here. It will be of type text, okay, and not null condition for this. It cannot be null. So text type will give this unlimited length string, okay, and not null is like it will required, like you cannot keep it null. You have to put something in this field, right? So like schema enforced here, okay, and sentiment is next. Sentiment, right? Where 10 and it's also not null. You have to put something here, okay, and where 10 is like it will be a string and its max length characters will be 10. Positive negatives fits fine in this case, right? Then we have confidence. It will be a float type. It is also not null. And then we will have created it. It's of timestamp, right? No default, and for now only. So timestamp will be autofilled at insert time, and every table should have one, right? That's it, and we will. Okay, so you can see it's now created, I think, right? Now we can insert some value also. Let me show you. Insert into test predictions, okay. It's like text sentiment and confidence, right? Okay. Values will be like this. So we are defining the predictions table. These we are mentioning the columns, right? Then values will be this. Text will be you can give it, this is a wonderful, right? And it's a positive sentiment, right? As you can see, and 0.9 is the confidence in this case. Let's say 95 here, right? And it's correct. So we inserted a row and we created a table. Now it's time for from the database we like retrieve some information if it is there or not, right? Let me write some select asterisk from test predictions. So it should because we already inserted one row, right? So it's all like return id 1 because it's auto incrementable, right? And timestamp because you never wrote them, right? And the database working is there. Okay, is it, did it select? No, it didn't form. Okay, this is like wrong query, I think. Okay, select asterisk from test predictions. It's not returning, guys. What happened? Okay, I think everything. I think I messed up in here. Okay. Uh, I think I need to quit it. Okay. I need to sudo. What is the command for this? U Postgres PSQL. I need to do this again. PostgreSQL. Okay, it's again running. I think I have already database, right? Database already there. Just I need to do this command. Review radar. You are now connected to database review radar as a Postgres. Okay, I am there. So now I can create this table, right? Create table test predictions, right? This table will be like id of this serial type, and it's a primary key for us, and we have text of type text only, and not null also. Then we have this sentiment of where care of 10, right? And it's also not null. Then we have confidence of type float, right? Not null it is also, and we have created at of type time stamp or default, and now, right, we did it. So create table is there. Okay, so created table is created, I think. Now we insert something into this. Insert into test predictions, right? With three things. We have text, we have sentiment, and then we have this confidence, right? And after insert into this table with the values of this text will be this great product, let's say, and the sentiment is positive, and confidence is 0.95, let's say. Okay, so inserted zeroth ID. I think it's given 01. I don't know what it is. And let me try this. Select asterisk from test predictions. Right. As you can see, there is a table. First ID is there. Growth product is the review. Positive is sentiment 095. You see what's happening here. A time stamp, you never wrote this, but it is 2 days time stamp, right? 26/7/26, and this is the time here, and great product like that. So isn't it very like like magical, right? Now we drop this table, okay, because we just tested it, okay. Drop table this test predictions, because we just want to test that, right? And drop the table, okay, and we cut this PSQL now. So PSQL is quoted. So you are now written raw SQL from your end, right? You created a table with a schema and inserted, selected something, dropped that also. So everything the ORM does from here on, you have done by hand once, okay? So this ORM will do everything for you from now on, okay? That's what that's the deal we made. Secrets done right, the ENV. Okay. Thank you so much for watching, guys. We will meet you tomorrow, okay? One, two, three,